So as we said, we may try different formats of transformations, right? Because we always have many ways to transform a given variable. For example, when we were trying to capture the nonlinear relationship of house price and house age, we actually may want to choose a quadratic term, okay? Because quadratic term gives us a parabola, and we know the shape would be something like this, or something like that, right? We have a curve, a nonlinear curve, when we have a quadratic term here. Okay, so that means the idea is the following. Previously, we tend to believe that house age affects house price in a nonlinear way. So we tried 1 over x3, but we failed. We shouldn't say we failed. We were good, but it's not better than using age directly. But that's not the end of the story, because nonlinear relationships may be expressed by multiple ways. Quadratic is another possibility. So if we have some time, we should try this. If we tend to believe that the nonlinear relationship exists. Okay, so now we can include one dependent variable and the 3 independent variables in our model. We need to prepare this column by ourselves. Okay, we need to calculate this column according to the original age. We need to calculate those age square by ourselves and then input the 3 columns as independent variables. Software would give us the following regression report. We can see that, oh, not good, because only 1 star here. Size is still significant, but not as significant as in the past. Plus, age and age square, they are just useless variables, right? We can see that they are just useless. So that means when we want to use this equation to fit our given sample data, it's very hard because the pre-assumed assumption restrict us from fitting from a good fitting. The software would try their best to optimize beta 0, beta 1, beta 2, and beta 3, but because of this functional assumption, it's just bad. It's just bad. So we can see that, okay, well, indeed R square is good because we have more variables, but adjusted R square is actually worse. Okay, it's actually worse. Plus, variables are not significant. We have no evidence that age and age square have impact on the house price. Okay, so given that, this is not a good idea for that particular data set. In general, when you suspect a nonlinear relationship exists, you probably want to try a few possible transformations. Okay, here are some popular transformations for nonlinear relationships. This black line is x. This is the linear relationship. If you tend to believe that when x goes up, y would also goes up, but the marginal effect will decrease. Then you probably want to try log or square root. On the other hand, if you tend to believe that when x goes up, y would also goes up, and the marginal impact will increase, then you probably want to try x squared or even x cubed. That's both possible. Finally, if you believe when x goes up, y would go down in a nonlinear way, in a reciprocal way, then you probably want to try 1 over x. Please note that when we are drawing these curves, we assume that the coefficient is positive, but the coefficient may actually be negative. Okay, so that means you may measure some impacts that's different in the shape. For example, if you are talking about reciprocal, okay, reciprocal is something like this. then if the coefficient is negative, then you're going to get a relationship like this. So if your scatter plot shows you a relationship like this, okay, x is here, y is here, and is increasing, but gradually not so significant, you probably want to still try 1 over x, because if it's a good fit, the software will give you a negative coefficient for that. Similarly, if you are talking about, for example, square root, then if its coefficient is negative, it's going to be something like this. Okay, so it can also be used to fit data with a decreasing pattern. Okay, so they are something to consider in general. They are something to consider. There are many applications that you assume one variable affects the outcome in a linear way, then you see the variable insignificant. However, the true relationship is actually nonlinear, so you need to really find a way that measures the nonlinearity, and then the variable becomes significant. Now that's possible. So transformation is really something you need to consider. Okay, so in general, we may have a lot of candidate independent variables. Okay, size, number of bedrooms, age, distance to a park, distance to a hospital, safety in the neighborhood, etc. So if we consider only linear relationships, the task is still difficult, because if we have p candidate independent variables, for each variable we may include it or not, and at least we need to include one. So we can have 2 to the power of p minus 1 combinations. We need to try so many different regression models to see which one is the best, right? Plus, for each variable, we have actually many different ways to transform it. And if you consider nonlinear relationship, actually the ways to transform a given variable is infinite. There are infinite ways to transform a linear relationship to a nonlinear one. So there is really no way to try all the possible combinations. Okay? So that's really some difficult task to do. That's really some difficult task to do. We want to find the best regression model, okay? Given a set of independent variables, the software can help you find the best coefficients. That's easy. But we need to somehow find a best combination of independent variables, either in linear or nonlinear ways. That's hard because the software cannot do that for us. So how may we find the best regression model? Well, my answer would be the following. There is no such best model, or at least we do not try to look for that. We try to look for good enough models. Okay? So when we have a good enough model, and after a reasonable amount of time of searching or improving, if we just cannot do that, we would stop. And there is really no reason to search for a best model because it's too difficult. There are some general suggestions to help you move toward the good model. First, for each independent variable, you would take each of them one at a time and observe the relationship between it and the dependent variable. A scatter plot typically helps, and use that to consider, first, whether you want to include that variable, and second, whether you want to do variable transformation. One possibility is that in the scatter plot, you see there is really no correlation between the two variables. If that's the case, most likely you don't need to consider that in your regression model. If you can see some kind of patterns, then you check whether it's a linear pattern or not. If that's not, then you try a few variable transformation. But if it just looks like linear, then there's really no reason to try nonlinear transformation. Second, for each pair of independent variables, you may want to check their relationship. If any two are highly correlated, then quite likely you don't need one of them. Then you may just select one to be the representative. Finally, once the model is built, check the p-values. What we will do is to first select a set of independent variables, build a model, and then check their p-values. Typically, we remove insignificant variables. Okay? Once we remove them, we probably use the remaining variables to do the regression fitting again, or we introduce some new variables. It depends. But one thing to keep in mind is removing a variable may change the significance of other variables. That's possible because you have a regression model as a whole. Okay, so when you do the fitting, you estimate coefficients, and when you have different number of variables, the coefficients may just change. So we really need to go back and forth to try various combinations. No one can really help you. You need to do that by yourself. We must stop when we have a good enough one. Otherwise, the search will just take an infinite amount of time. Okay? So we would stop if we can see a high enough R-square and R-square adjusted, and when we can see some small p-values. What we want is to see whether one variable, whether a set of variables affect the other. What we want to do is to check what are those variables that can affect our target and how significant they are. That's our subject. Okay? And we need to go back and forth to try various combinations. Many software, they try to facilitate this process, but what I can tell you is that the power is limited. The software just cannot do a lot of things. For example, it cannot help you to decide transformation. All it can do is if you give it 10 or 20 variables, it do some kind of heuristic search to reach one subset of variables and report that to you. But it cannot even guarantee whether it is optimal among all possible combinations. Okay? Plus, it cannot decide transformation or some more things. So we really need to find a model by ourselves. Or sometimes if we just cannot find a good one, we may need to think about whether we miss some important independent variables. Okay? So regression is powerful, useful, but it's also hard because you need to do a lot of things. Sometimes intuitions and experiences may help. When you have a lot of variables, your intuition or experience may tell you some are important. Deal with them. But also, sometimes your intuition and experiences may just hurt you. Because if you only rely on intuition and experiences in selecting variables, you probably may miss some important information that nobody knows. Okay? So that's important. Okay, a quick summary. With a regression model, we try to identify how independent variables affect the dependent variable. With such a model, we adapt the least square criterion for estimating the coefficients. Eventually, you will just use software. You don't need to use that formula, but I hope you understand what's the basic principle. It's least square approximation. We need to do model validation. The overall quality is measured by R-square and adjusted R-square. Please understand their meanings and know how to use them. We may test the significance of independent variables by their p-values. Small p-values means significant. When we have the model building issue, we need to worry about whether we need to do variable transformation, and variable selection is also a tedious but important process. So these are something we did today. There are some more things to introduce in future lectures. We need to know how to deal with qualitative independent variables. Okay, that's very important. We need to know how to model interaction among independent variables. So we're going to define what do we mean by interaction, and then try to tell you how to deal with that. Okay? We need to avoid the endogeneity problem. Endogeneity somehow means the dependent variable also has an impact on independent variables. If that's the case, then the model would be problematic. We need to be aware of that and try to avoid that. And then finally, we want to do some more advanced analysis to further validate our model. So there are some more things to do, okay? Because eventually a regression model would be used to predict the future, which is one of the most difficult thing in the world, in the business world. So you really hope that your regression model is accurate. Okay? So once you have a regression model, you check R-square, you check adjusted R-square, you check their p-values, and you do some more thing to make sure that your model can be used. Or even if you fail those tests, you try to understand that and use your model carefully. Okay? So that's something to do. Thank you.